Hello students, welcome to CM Hub, where you, me and chemistry connect with each other. This platform is a gateway for mastering chemistry. In the previous episode, we discussed the balancing of equation by ion-electron method in acidic medium. We learned the rules for balancing the equation, and then we also concluded that to balance hydrogen in basic medium, we follow the same rules as that of acidic medium, but the only difference is in the addition of OH minus group. I have also told you that I will be explaining the balancing of equation in basic medium with an example. But prior to that, let us understand the different types of redox reactions. The first one is a simple redox reaction. A simple redox reaction is that in which we have two different reactants, one undergoing oxidation and another undergoing reduction. The best known example that we can take is Zn plus Cu2 plus gives rise to Zn2 plus Cu. This is reactant 1, this is reactant 2. These are two different species. Here zinc is undergoing oxidation, copper ions are undergoing reduction. We have dealt it in the earlier episode. When there is an increase in the oxidation state from reactant side to product side, it is said to undergo oxidation, and if there is a decrease in oxidation state, then it is said to undergo reduction. This is a simple redox reaction. But if we take another example, P4 plus OH minus gives PH3 plus H2 PO2 minus. Here we find that the same reactant P4 undergoes both oxidation as well as reduction. The same reactant in basic medium is giving different products, in which the central atom or the atom which is undergoing a change is in different oxidation state. Such redox reactions in which a single species undergoes both oxidation as well as reduction, we call them as disproportionation reactions. Here the oxidation state is -3, here the oxidation state is +1, 0 to -3 this is reduction, 0 to +1 this is oxidation. There is a third category of redox reaction called comproportionation reaction, in which two different oxidation states of the same element give rise to a product in which the oxidation state remains the same, which is intermediate to that of the two oxidation state of the reactants. So here this is reactant 1, here this is reactant 2, but both belong to the same element. Here copper is in +2 oxidation state, here copper is in 0 oxidation state. +2 is changing to +1, 0 is changing to +1. Both of them are giving rise to same product in which the oxidation state is intermediate to that of the two reacting species, +2 and 0 intermediate +1. Such reactions are called comproportionation reactions. Let us take one example of the disproportionation reaction in basic medium and understand the balancing of reaction in basic medium. The example that I take is Cl2 plus OH minus gives Cl minus plus ClO3 minus. Here chlorine is changing from 0 to -1, this is reduction. Here chlorine is changing from 0 to +5, this is oxidation. The same species is undergoing both reduction as well as oxidation, so we say chlorine is undergoing disproportionation, and this disproportionation is taking place in basic medium. So let us take this example and try to balance the equation in basic medium following the rules that we have already learnt in the previous episode. I'll split the reaction into two halves. One, Cl2 gives rise to Cl minus. The second, Cl2 gives rise to ClO3 minus. Let us balance the step 1 first. Balance elements other than oxygen and hydrogen. There are 2 chlorine, so I go for 2 Cl minus. Chlorine is balanced. Now there is no oxygen and there is no hydrogen, so no need of worrying about the balancing of hydrogen and oxygen in the step 1 equation. Now directly balance the charge. On the product side, each chlorine is -1. There are 2 chlorine, so this is -2. On the reactant side, it is 0. So 0 minus of -2, because higher oxidation state minus lower oxidation state, 2 electrons are involved. Now where should I add those 2 electrons? I should add those 2 electrons to the side where there is an electron deficiency, because there is 2 negative charge on the product side. If I add 2 electrons on the reactant side, now the charge on the reactant and product become the same. 2 negative on the reactant side, 2 negative on the product side. Now same, balance the second step equation. 2 chlorine, 2 chlorine. Step 1 balancing elements other than oxygen and hydrogen is done. Now there are 6 oxygens on the product side. So go with the same rule that we have learnt in acidic medium to balance oxygen. Add the deficient number of water molecules to the side deficient in oxygen. So 6 oxygens are there, so deficient 6 water molecules are added to the side deficient in oxygen. Now balance hydrogen. Follow the same rule that we learned in acidic medium. Add the deficient number of H plus ions to the side deficient in hydrogen. 6 into 2, 12. So I add 12 H plus. But now this is not acidic medium, this is basic medium. So we need to introduce the OH minus group. The rule that we have followed is same in a basic medium and acidic medium up till this step. But now here is a game changer. I have to nullify the 12 H plus. So what I do is I add 12 OH minus ions to the side where there is a H plus ion, so that the H plus and OH minus convert into water, and at the same time add 12 OH minus ions to the other side. Because here I have added 12 OH minus to the product side to nullify H plus, I am simultaneously adding 12 OH minus to the reactant side. So 12 H plus and 12 OH minus convert into 12 water molecules. So I rewrite the equation 2ClO3 minus plus 12H2O. This becomes Cl2 plus 6H2O plus 12OH minus. Now 12H2O on the product side, 6H2O on the reactant side. So I take over 6 water molecules to the side where there are 12. So 12 minus 6, it becomes 6H2O. Rewrite the entire equation once again. Cl2 plus 12OH minus gives 2ClO3 minus plus 6H2O. Now there is negative charge on OH. There are 12 such negative charges on the reactant side, 2 such negative charges on the product side. So minus 2 minus of minus 12, that is 10 electrons. So I need to add 10 electrons to the side where there is a deficiency of electron. So I add 10 electrons here. Now this is the final form of the equation after adding OH minus. But now we need to add the step 1 equation and step 2 equation. This is step 1 equation. Now this is step 2 equation. I need to add these 2 equations to get the final equation by nullifying the electrons. Because I told you in the last episode, the simple logic that the number of electrons lost should always be equal to the number of electrons gained. Let us take only those 2 steps. Cl2 plus 2 electrons gives 2Cl minus. Cl2 plus 12 OH minus gives 2ClO3 minus plus 6H2O. This is plus 10 electrons. Now I multiply this equation by 5. 5 into 2, 10 on the reactant side, 10 on the product side. Now let us add the 2 equations. 5 chlorine plus 1, 6 chlorine. So 6 Cl2 plus 12 OH minus gives 5 into 2, 10 Cl minus plus 2 ClO3 minus plus 6 H2O. I will take 2 as a common factor. So divide the entire equation by 2. So the final equation becomes 3Cl2 plus 6OH minus gives 5Cl minus plus ClO3 minus plus 3H2O. Now cross check whether everything is balanced. 6 chlorine, 5 chlorine plus 1, 6 chlorine, 6 oxygens, 3 oxygens here, 3 oxygens here, 6 oxygens, then 6 hydrogens, 3 into 2, 6 hydrogens. Balance the charge, check the charge. 6 into minus 1, minus 6. 5 into 1, minus 5, plus this is minus 1, total minus 6. So now even the charges are balanced. But the entire purpose of this episode is to make you understand that it is not difficult to balance the equation in basic medium, because many students get confused to balance the OH minus ions. I repeat, follow the same rules that you have learned in acidic medium up till H+. After that, to balance hydrogen in basic medium, add the same number of OH minus ions as those of H+ to convert it into water, and simultaneously add same number of OH minus ions to the side where there is no H+. So I hope you have understood this concept of balancing the redox reaction in basic medium. In the next episode, we will connect again in CM Hub with another interesting concept. Take care. Bye-bye.